Okay, I'm not going to go over the entire empirical formula lesson from the very beginning, but just to remind you our little jingle. Percent to mass, mass to moles, divide by the smallest, multiply till whole. Those are the steps you want to use to help you solve a problem when you're looking for an empirical formula. Remember, the empirical formula is the lowest whole number ratio of elements in a compound. Let's look at some problems on your worksheet. Okay, here's some practice problems we can do together. What is the empirical formula or the lowest whole number ratio of the elements in the compound below? So I'm looking for the empirical formula, the lowest whole number ratio formula from a compound that's 75% carbon and 25% hydrogen. So the first step is percent to mass. That means I'm assuming I have a 100-gram sample, which means I would have 75 grams of carbon and 25 grams of hydrogen. Next, I need to change from mass to moles. So I'm going to divide by the molar mass of both. 12.0 grams per mole for carbon, 1.01 grams per mole for hydrogen. $75 divided by 12.01. I don't know where I'm getting 12. That's the number, but I only need to do it to 2 sig figs. Is 6. I'm going to use 3 for now because you'll see it won't matter. 6.24. And that's moles of carbon. And then 25 divided by 1.01 is 24.8 for hydrogen. Okay, and then our jingle says after percent to mass, mass to moles, divide by the smallest. Well, 6.24 is the smallest one. So I'm going to divide them both by 6.24 and divide this by 6.24. So this comes out to 1, and 24.8 divided by 6.24 is 3.97. Which is close enough to round it to 4. So we had 1 for carbon, so I write C with a 1 subscript, and 4 for hydrogen, so CH4. Okay, let's try this one, potassium and chlorine. 52.7 grams of potassium. I'll write it a different way this time so you can see it as a fence post. And 47.3 grams of chlorine. So we change percent to mass, okay, and then mass to moles. So here goes the fence post way. Potassium is 39.1 grams of potassium for 1 mole of potassium. This is 35.5 grams of chlorine for 1 mole of chlorine. These numbers came off the periodic table. 52.7 divided by 39.1 is 1.35 moles of potassium. What did I do there? And then the chlorine one is 47.3 divided by 35.5. Which is 1.33. Those are awfully close together. Okay, and so I did percent to mass, and then I changed from mass to moles. Now I have moles, I divide by the smallest, so divide them both by 1.33 moles Cl. And this is basically 1.01, and this is a 1.0 ratio. So there's 1 potassium and 1 chlorine, which is KCl. Okay. Let's do one more. How about this? Let's do this magnesium and bromine one. I have 13 grams of magnesium and 87 grams of bromine. Magnesium is 24.3. And the bromine is 79.9. Thirteen divided by 24.3, 50. No, sorry, it's 0.535. And for the bromine, 87 divided by 79.9, 1.09. Divide by the smallest, so I divide them both by 0.535. This is 1. And this one is 2. So that's 1 mg and Br2. Which is as it should be because magnesium has a +2 charge. Okay. Sorry, get where you can see. MgBr2 is the answer. Magnesium is +2 and bromine is -1, and if you crisscross them you get MgBr2. This is a good way to check yourself if it's an ionic compound.